Good evening all. Audio video clear? Please mention whether the audio video is clear. So today we are discussing, or today we are starting the permutation combination unit, a very important unit. Number system unit we have completed last class. Let me just check whether the audio video is clear. Those of you are watching me live, please mention whether everything is perfect. Very important unit. Number system unit we have completed last class. Okay, so let's start. So permutation combination is a chapter or unit that many people think that it is very difficult or it cannot be done at all. And some people, the problem is maybe you haven't learned it in school, because in school it was there in the 11th class NCERT textbook, it was there. In other syllabus also I think it was in 11th or 12th only. So some of you may not have a proper idea about this unit, so I will start from the basics. Even if it is a 30 minutes lecture, in this 30 minutes I will try to cover up as much theory as possible. So in this course, this unit of permutation combination will be covered in 3 lectures. First lecture will be fundamental principle of counting, second lecture will be anagram and number puzzles, and third lecture will be permutation combination. Yeah, all these are permutation combination unit itself. But after building the concepts of fundamental principle of counting and using that, doing anagram problems or number rearrangement problem, then if you hear about this permutation combination formula, then it will be easier. Actually, as I told, this seems like a difficult unit, but once you understand the logic behind it, is very simple. So these 3 lectures will be based on this unit itself. Okay, for the new student, just giving an introduction. My name is Christy Varghese. More about me you can see here, and these are the books I have written, and these are the courses that I offer in our mobile application Christy's classes. The flashcards I am displaying in the class, that is available as an ebook in the mobile application itself. And for CSIR NET exam we have a paid course now. For GATE also there will be paid course that will be starting very soon, and for UPSC we will be starting paid courses but later only. And if you want to follow our free resources or social media handles, these are the handles: Telegram channel, WhatsApp group, mobile application, and our blog. Blogs are updated in the website christyvarghese.in, and in this YouTube playlist or YouTube channel also you can find many playlists for different exams, for UPSC, for GATE, for CSIR and other exams also. So all of you are welcome to be part of this initiatives. Okay, so let us start. Permutation combination. The first idea you should learn is fundamental principle of counting. Today's topic is primarily on this topic, on this area itself, fundamental principle of counting. Thank you so much, Rakhi, for the good words. Thank you for the encouraging words, because that is always needed for any educator to continue with better energy. Okay, so what is fundamental principle of counting? There are 2 versions for this: multiplication rule and addition rule. Multiplication rule says that if one thing can be done in m ways, another thing in n ways, both the thing together can be done in m into n ways. Again, when you hear like that, it looks like a clumsy theorem or clumsy formula, na? And there is an addition rule version also. So I will make you understand this so that it is easy for you to learn and do questions with this. So can you do this small task? Count the number of balls that is visible on the screen. Can you find how many balls are there on the screen? This white colored balls, I think it is properly visible in your devices. Any answers? Very good. Some of you got an answer. 20 now. And to find that 20, I am sure that you didn't count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. This is not how you counted. I am sure about it. Isn't it? Then how you may have counted? There are 5 rows now. 5 rows are there. And each row have 4 balls in it. So total number of balls you counted 5 into 4. And this is called fundamental principle of counting. 5 ways you can choose rows, 4 ways you can choose columns, or 4 ways you can fill balls in each row. Then total number of balls will be 5 into 4. If m ways you can do one thing, n ways you can do another thing, both the thing together can be done in m into n ways. Selection of rows can be done in 5 ways. Filling of rows can be done in 4 ways. So both the thing together are needed to count all the balls. So 5 into 4. So you already are doing fundamental principle of counting in your real life. That is what I am trying to say. When you go to a movie theater, think that every row have 12 chairs in it. And there are such 20 chairs. So the number of chairs in the movie theater or number of seats in the movie theater is 20 into 12. There also you are using this fundamental principle of counting now. So this is nothing new. This is already known, or already you are familiar with this. And believe me, permutation combination chapter, maximum number of question is based on this multiplication rule alone. Yeah, there are formula for permutation, formula for combination, but more than all that, you have to know this fundamental principle of counting. Is it clear? Then one more illustration. As for the new students in this course, in 30 minutes, the first 15 minutes, around 15 minutes, we will be spending on the theory of the topic, and then we will discuss the questions related to the topic. That also previous year questions we will be discussing. So make a try, all of you. In real life also, this situation you can actually think about. For example, in your wardrobe, you are seeing that 3 shirts are there, 4 pants are there. You are thinking like, how many combinations I can make, or how many different outfits are possible. Can you think about it? Due to lack of time, I will start explaining. 3 shirts and 4 pants now. To make it interesting, I have taken an image to make you understand. So if I fix the first shirt, I can choose pant in 4 ways now. First pant, first shirt, 4 pants. Shirt 1, pant 1, shirt 1, pant 2, shirt 1, pant 3, shirt 1, pant 4. So 4 choices for that. Similarly, shirt 2 also have 4 choices now. Shirt 2 also have 4 choices. Shirt 3 also have 4 choices. And we are okay with shirt 1 choice also, shirt 2 choices also, shirt 3 choices also. This or this or this. Or means addition. So 4 plus 4 plus 4. That is called fundamental principle of counting, addition rule. M ways of doing something, n ways of doing another thing. Then m plus n ways are there. That is either this or that. Yeah, in a simpler way we can say either of the things can be done in, this is m plus n ways. M plus n ways. That means combination with shirt 1 is okay, combination with shirt 2 is okay, combination with shirt 3 is okay. So total number of ways are 4 plus 4 plus 4. Now some of you may be thinking, why we need to add 4 plus 4 plus 4? You can just say that, just like previous question, you can say that shirt can be chosen in 3 ways, pant can be chosen in 4 ways. So 3 into 4. Yeah, that is what I am trying to say. This multiplication rule and addition rule are just 2 versions of the same theorem itself. It is not different. Multiplication is repetitive addition. That is how these two are same itself. In different scenarios we use multiplication rule or addition rule, but multiplication rule is more important. Did you all understand this? So 3 into 4 ways. Now how this is practically helping you in questions, that I will explain. This idea extended is this combination formula, permutation formula, about which we will be discussing in the next lecture. Permutation combination, again, once again I am clarifying, this unit is permutation combination. Fundamental principle of counting is also part of it, but the formula permutation combination we will be discussing only in the next lecture. And when to use permutation, when to use combination, about that also I will give you clarity, because these are some common doubts or mistakes students make. That is why we will discuss that in the upcoming 2 lectures. Okay, so this much is clear, I guess. Then I will show you few practical questions where you can use this. Okay. These are called network type problem, which is one major type of problems where fundamental principle of counting can be directly used. So make a try, all of you. Today more concepts we will learn with previous year questions itself. Some of you already got the answer. There are 4 routes to travel from city A to city B. So city A, city B. A to B there are 4 routes. For example, if I am calling them PQRS. And 6 routes from B to C. B to C routes 1, 2, 3, 4, 5, 6. I will call them TUVWXY. Then total number of routes possible from A to C means A to C can be traveled only via B. So A to B, P have 6 choices now. Just like shirt 1 had 4 pant choices. P have 6 choices. Q have 6 choices. R have 6 choices. S have 6 choices. So 4 parts have 6 choices each. So 4 into 6, 24. Again, fundamental principle of counting. All clear? Please respond. And same thing was asked multiple times in previous years. This is not limited to 2 sets only. It can be extended to any number of sets. For example, this question, due to lack of time, I will start explaining. With reference to the given figure, number of different routes from S without retracing. Retracing means you cannot draw the path again. Like if you gone through this, you cannot repeat the path again. That is retracing. So retracing is not allowed. From U and or V. That means S to T you have to travel. For that, first you have to travel S to U, then U to V, then V to T. S to U itself you have 3 choices. Now like previous question, if A, B, C are the 3 choices. For each of A, B, C there are D, E 2 choices each to go from U to V. And for each of A, B, C, D, E have 3 into 2 choices, 6 choices. For each of those 6 choices, there are F, G, H, 3 choices remaining. So 3 into 2 into 3 choices totally. Are you all understanding how 18 is the answer? So this idea can be extended. That is what I am trying to say. The previous question it was only 2 sets. Here it is 3 sets. Same thing. You can just repeat. Clear? So in the networking type problem, you can do this fundamental principle of counting. This question you can try as homework. This is a little advanced version of the previous question. Solution I have given, go through it. It is easy only if you read it properly. Okay, now this was a 2022 previous year question. Make a try. These kinds of questions are very common in all competitive exams. Not only UPSC, in CSIR, GATE, bank exam, PSC exam, these kinds of questions are very common. So today's topic is a universal topic of all competitive exam, we can say. Almost all competitive exam have this topic. Questions related to fundamental principle of counting. But the problem is many people misunderstand this chapter as this chapter is very tricky because permutation formula, combination formula, that is the key to do most questions. That is what many people think. That is totally wrong. That is because your base is not strong. If your base is strong, it is so simple actually. So please try. I'll give 1 minute, all of you try. Okay, some of you got an answer. Very good. So one non-zero digit, one vowel and one consonant from English alphabet are to be used in forming passwords. Yeah, in real also for passwords there will be some rules now. There should be special symbols. Yeah, different rules can be there. There should be capital letter, there should be small letter. But here the rules are little more simple. One non-zero digit. So 1 to 9 digits can be 1 to 9, any of those digits. That means the digit part. Question also says such that each password has to start with a vowel. Vowel I am denoting by V. End with a consonant. Consonant I am writing C for consonant. And middle definitely then it should be digit now because it is 3-digit password, vowel, consonant and non-zero digit. So D for digit. So this is the structure of the password. So this vowel can be filled in how many ways? Compare it with that shirt analogy we discussed in the beginning. Shirts can be chosen in 3 ways. Now 3 shirts were available. So vowels were available in 5 ways because A, E, I, O, U are the vowels in English alphabet. So 5 ways. And digits non-zero. If zero was allowed, 10 possibility, but non-zero means 9 possibility, 1 to 9. Consonants, 21 consonants in English alphabet. Now using fundamental principle of counting. For example, if I write A, E, I, O, U, for A itself 9 digit combinations are there. Now A1, A2, A3. Compare it with that shirt analogy, then you will get more context or more clarity. Similarly, A have 9 choices of digits and that 9 choices have 21 choices on consonants. Similarly, E have 9 into 21 choices. All 5 numbers are 9 into 21 choices. So 5 into 9 into 21. All of you are clear how 945 is the answer. 5 into 9 into 21 and all, how to multiply it faster. You can check out my speed matrix or Vedic math classes. Vertically and crosswise sutra can be used to do multiplication faster. Okay, that is not today's topic, so we'll skip that for the time being. All of you understood this? This question can have many variations. In this question, to be frank, it is easier. The same question in GATE exam in a twisted way they have asked. Instead of saying that it should start with a vowel and end with a consonant, they can ask the question like this. Vowel consonant digit can be anywhere. That means that is little more trickier. So vowel digit consonant is possible, vowel consonant digit is possible, digit vowel consonant is possible, digit consonant vowel is possible, consonant digit vowel is possible, consonant vowel digit is possible. So that itself has 6 arrangement. That is called external arrangement. So that kind of question in UPSC, it was asked 1 or 2 times only. There what you have to do is internal arrangement into external arrangement. If time allows, we will discuss that in the next class. Internal arrangement into external arrangement. 6 into 945 would have been the answer if the question was like this. That means there is no restriction where should be the vowel, where should be the consonant, where should be the digit. In that case, answer will be 6 times 945 or 3 factorial times 945. Don't worry about that for the time being. Today's topic we will just limit to this. Okay, is this clear? Then we will see latest 2 questions from this area. Many people had doubts with this question and this question. So we will discuss that 2 doubtful questions. So please try this. Very good, Avanish. You told it right. Jagdish, now it is clear now. Yeah, all of you are welcome to mention your doubt in the live chat. Those of you watching this recording, you can mention your doubts in the Okay, Karnika. Yeah, some people told that there is some audio issue. I am working with the team. Actually, my team is not available now for checking this. That is why maybe in 2-3 days we will get better audio quality. And thank you for the good words also, Karnika. Good to know that you are following the classes for the last few years. Okay. Good to know, Jagdish. Okay, this question all of you try. So this is little more advanced version of the previous question, but the idea of fundamental principle of counting is the base for this question also. But here it is not that straightforward as saying that 4 shirts and 3 pants. Here you need to identify which all position, what all to be filled. Compare it with the previous question. There it was very clear. Non-zero digit means 1 to 9, 9 possibility. Vowel means A-E-I-O-U, 5 possibility. Consonant means 21 possibility. But here you should get that clarity. So I will make you understand this clearly. I will explain, listen carefully. A flag has to be designed with 4 horizontal strips. So these are the 4 horizontal strips if you just imagine. Using some or all of the colors red, green and yellow. Red, green, yellow, these 3 colors can only be used. What is the number of different ways in which this can be done so that no 2 adjacent strips have the same color? Adjacent strips should not have same color. For example, here if you put red, you cannot put red here also because that is adjacent strips now. So that is the only condition mentioned, and red, green, yellow, these 3 are available. So what you can do is, you can start from an arbitrary position, or here the strips, this one, this position. If you think about it, what all you can put? You can put a red, you can put a green, you can put a yellow. There is no restriction at all, na? Just like you go to a buffet dinner, you are the first person there, so you will be seeing all the items there. If you are going later, you may not see some of the items. Some of the items may be finished. But the first filling have all choices because there is no restriction at all. Na? Adjacent stripe comes only when you think about the second stripe, na? Second position. So thinking of the first position, you can fill any of the 3 color. So 3 ways you can fill this position. Compare it with the previous question. 5 ways you can fill the vowels. Likewise, here 3 ways you can fill this. Clear? What about the second one? Now the reality is fixed that Here we already put a color. What is the color? Red or green or yellow. For example, if you are fixing red, here you cannot use red anymore. You can use green or yellow. If you are fixing green, you can fix yellow or red. If you are fixing yellow, green or red are available. That means whatever is the color you are fixing here, that color is not possible for the second stripe. That is why two possible colors only here. Are you all understanding? Which are the two possible color? We can understand only if we know what was the color we filled here. That have three possibilities now. Just like the shirt analogy. Shirt 1 or shirt 2 or shirt 3 or shirt 4. We don't know which we choose. We have all choices. Same way, three choices here, then two choices only here. Two choices means you filled a color here. That color cannot be used here also. That is why two possibility. But the color used here can be used here. For example, if you fill a red here, green here. Again, if you want, you can put a red. Again, if you want, you can put a yellow also. That is why two possibility. Na? This is just an example. So two possible colors here. Same way, this stripes adjacent is this one. There you cannot use the color that is used here, but any other color can be used. So two possibility here. Now this have that many arrangements or permutation combination possible now. How to find that? Using fundamental principle of counting. 3 into 2 into 2 into 2, 24 choices. Is this clear? All of you please respond. Yeah, do let me know if you are understanding. By hitting the like button also you can express that you are understanding, because that will help this video also to reach to more and more people. So if you feel that this is an initiative that is supporting students, keep supporting this initiative by interacting in this video or commenting in this video, because that is how YouTube recommend this to maximum more aspirants. Okay, clear, right? Any doubts, please ask. And this was little more trickier version of the previous question, but now you may get little more clarity already when you are trying the question. Tricky question but doable question now, I guess, because you already have seen question of this type now. Sure, Anindita, I will do that. I'll do that. Ashwin, I don't think for this series it is possible because we already have scheduled the series in YouTube. Let me see if anything can be done. I will do that, but most probably it will be in YouTube itself. Thank you so much, Samia. Thank you so much for the good words. Yes, Riju. Just try. After that, I will explain. Four factorial, can you tell the reason, Samia, how you end up at 4 factorial? Okay, some of you got an answer. Okay, so due to lack of time, I will start explaining. There are 5 persons PQRST, each one of whom has to be assigned one task. So compare it with the previous questions, then you will get little more clarity. In previous question, what was the challenge? We have horizontal stripes to be filled with colors. So stripes and colors are the two variables. Now, in the last question, what is it? 3 positions are there. Character characters to be entered, vowel, consonant, digit. So characters and positions are the variables. In the previous question, path and routes or path and cities are the variables. Similarly, in this question, the variables are tasks and people. So the thing is that you can do this question in two ways. From the perspective of task also you can start. From the perspective of persons also you can start. That is totally up to you which way you do. I am starting with from the perspective of task. Each task who is assigned. Compare it with previous question. Each stripe what color is assigned. Same way each task which person can be assigned or how many possibilities are there. So, and these kinds of questions, here the constraints are more, the conditions are more. Neither P nor Q are assigned task 1. Task 2 must be assigned to either R or S. So there are two constraints. Listen very carefully. In these kinds of situations when multiple constraints are there, start from the constraint which have less number of choices. Start from the constraint which have more number of choices. Task 2 must be assigned to either R or S means, one second, neither P nor Q, task 1. Okay, so task 2, it is told, task 2 can be assigned with R or S. Task 1 cannot be assigned with P or Q means task 1 have three choices, R, S, T. So that have more choices. Start from the one which have less choices. I'm repeating, start from the constraint which have less choices. Less choices means task 2 have less choices. That is why I'm starting from task 2. Task 2 can be filled in how many ways? Either with R or S. So R or S, two choices. So that is the reality we are starting with. Filling task 2 with R or S. That means R and S is not up. R or S, one of them is not available for any other task. That is the logic. Those two people, one of them will not be available for any other task. Now the next constraint is this. So that constraint is for task 1. P or Q cannot be assigned task 1. P or Q means P, Q, R, S, T. P or Q cannot be assigned, and R and S, one of them already taken task 2. So out of R, S, T, only two choices are remaining, because R, S, from that only one person can be chosen, and T also is available. So R or S, one of them, and T. So total two choices only available for task 1. So all the constraints are done. Now task 3, task 4, task 5 can easily be filled. How? Task 3, we already filled a person for task 1, we already fixed a person for task 2. So, two people are not available. Who are they? We don't know. But two people are not available. Other tasks don't have any constraint. That is why the remaining three people anyone can be given task 3. That means task 3 is given to one person. So, that person is also not available anymore. So task 4 can be given only to the remaining two people, any one of them. So 4 people already used. So those 4 people are not available for task 5. There is only one person remaining. So total number of choices will be product of all these using fundamental principle of counting. So 24 is the answer. There are different ways of doing this question. I just showed one of the ways. And one challenge in these kinds of questions is, if you have thought in another way, making you think in this way is a bigger challenge, because in your mind you are already fixed with that perspective. Then either you try to continue with that perspective and correct it if you are not getting the answer. Otherwise, try to think about what I am telling now, or if you are watching this recording, pause the video or replay the video and see this part so that you get clarity. How many of you understood it? Can you please tell? Okay, Samya, but that was time consuming, Samya. Anshika, for this question or previous question? Task 1 can't be done with P or Q. It can be done with RST, so it should be 3 ways. That is what I am saying, Anindita. That is correct if you are starting from task 1. But the reason why I am not starting from task 1 have 3 choices. I want minimum choices. That is the shorter way of solving. That is the reason. Again, the logic behind why that is shorter is very time consuming. That is why I am skipping for the time's sake. Again, the objective of this course is those who are preparing for the upcoming exam, a final revision should happen, and those of you are learning this for the first time, or those of you are watching this for learning a concept, they should also understand. So to keep the balance, it is a challenge. So that is why many things we cannot start from the base. For that, we will start another series if possible. Okay, sure, Jagdish, sure. Okay, so all of you understood this. This was asked multiple times. In CSAT, it was asked in 2015, same question, almost same question. Just person 1, person 2, person 3, person 4, person 5 is replaced by PQRST. So you can do that way. And for other exams also, these kinds of questions are quite common. CSIR NET aspirants who are attending this lecture, the UPSC question was repeated in your paper. That is why these exams, many questions are similar only. That route question we discussed now. Chennai to here it is Chennai to Mumbai, Mumbai to Goa. There it was ABC or PQR. And the other question S to U, U to V. That same question was repeated in CSIR NET as a mouse traveling the path. The answer will be 2 into 4 into 3 into 2. And that question, password question, was asked in CSIR this way. And same question was asked in GATE exam also in 2018. This is the, I want all of you to try this question. This is the next version, next level of that question. That vowel consonant question. Now, I told you they can ask you that by rearrangement of the different characters. That way also it can be asked. Solution is given here. Pause the video and check it later. Okay, all of you please respond. Did you understand the concepts we discussed today? Compared to other chapters, it will take some time to understand, but once you understand this, any question from this area can easily be done. Permutation combination will be very easy topic. UPSC aspirants, last year permutation combination, the number of questions directly or indirectly together 10 questions were there almost. Because average chapter also there was a hybrid question from permutation combination, and one another chapter also 2 more hybrid questions were there. So permutation combination is an important unit. So this is the first lecture. Tomorrow and day after tomorrow we will have 2 more lectures on this unit. So if you have understood it, do let me know in the comment section, and do hit the like button, and do share it with maximum people, this playlist or this course. And those of you want to be part of our full-length courses, you can check it out. Currently for CSIR NET, and in the future for GATE, UPSC and other exams also, we will have courses in this platform. So stay tuned for that. And for UPSC, currently the flashcards are available. Those of you want, you can check it out. And these are the details of the CSIR NET course for the CSIR NET aspirants. And this is how you can be part of our free resources. Check the description of the video. There you can find the links of all these resources. And our Telegram channel, we post the homework questions of each class. So the Telegram channel's links are also available in the description of the video. And check out the other videos in the playlist. If you want previous year questions, all questions solved, for UPSC, in this playlist you can find it. For CSIR, you can find it in these playlists. And for GATE, you can find in these playlists. So that also you can use. Thank you so much for the good words, Avanish, Jagadish, Shruti, and all of you. So if there is no other doubt, let's conclude here. Thank you so much, Anshika, also. So welcome all of you. So let's conclude for today. Tomorrow 8:30 p.m. we will meet for the next lecture on permutation combinations. That is anagrams and number puzzles. Letters, how it can be rearranged, numbers, how it can be rearranged. That we will be discussing in tomorrow's class. So that that's it. No other doubts or concerns. Now the class is over. Today onwards we will just spare maybe last after the lecture is over. If you want to ask the doubts or any concerns regarding the course, you can ask. So I will wait for 1 or 2 minutes if you have any doubts to ask. राखी कौन सा क्वेश्चन का आंसर है? 1 minute, check it out. The product of two numbers is 24 times the difference of the two-digit number. Number system का है. What is the largest? Okay, राखी group पे share करिए. I will try to answer it there because it will take time to solve this question. But we will try to post it in the groups. Others also will try that, and if they are not getting the answer, I will try to share the solution. Okay. A previous question, I think that was a doubt that many of you may have. Why I am not assigning 3 possibility for, again, there are different ways of doing questions. I told you there are different ways of doing question. If you want, you can start from task 1, but the reason I didn't start is that will create more confusion. That is why my perspective or my way of solving this question was, I wanted to start it from task 2. That means task 2, what are the constraints of task 2? It can only be given to R or S. So for example, if I am giving it to R, now we are trying to fill task 1. So task 1 cannot be given to R because R is already assigned task 2 now. That is why task 1 have only 2 choices remaining. The reason not 3 choices because I started from task 2. Yes, you are right when you are saying 3 choices will be there if you are starting from task 1. But I don't want to go into that solution because that will confuse you. This solution and that solution will confuse you. Yeah, I can confuse you and then convince you if this was a detailed lecture. But in this 30-minute lecture, I don't want to. Yeah, that is definitely good to check the other perspectives and see how these 2 perspectives are the same itself. I mean, finally it is all ending up at the same thing itself. That's a beauty of maths, na? It is like there are many paths, but it all leads to the same destination. In math, unlike most other subjects, math, that is one beauty of it. Different ways you can think, but it all leads to the same truth. Like literally we were discussing about different paths that can take you to A to C, na? Same way, math also have different ways of doing. Okay, so I'm finishing today's lecture here. We'll plan for more such sessions or more such series where we will discuss more about these kinds of perspectives of different ways in which you can look into a question and all. So that's it. Thank you all of you, and new students, about different ways of doing questions. 15 shortcut approaches of doing aptitude question that we have discussed in previous lectures. Check it out. In UPSC playlist also it is there. In CSIR playlist also it is there. In GATE playlist also it is there. So thank you. Take care. Bye bye. Have a good night. See you all on the next class. Take care.